Hello everyone, welcome back to my channel Ravi Dhaba Programming. So in this session, I'm going to discuss about the Java collection framework. So Java collection framework is a collection of different data structures that you are going to use in your programming. So what happens is, like, if you remember, when we were discussing about the Java arrays, right, to keep the multiple information. Let's say there is a user information, right, and user has a name, first name, last name, address, let's say his contact details, his some of the personal details. Maybe he's related to some school, college, university, or maybe he's employed somewhere else. Then in that case, all those details will go into a particular class. But what if I want to collect multiple user details, maybe the multiple students detail or multiple employee details? In that case, how can I store all the details in one particular data type, right? So if you go with the primitive or the wrapper class, it don't support uh, to keep the different kind of uh, data, or you could say, like, let's say I'm having one employee class, and I cannot put that employee class into any primitive or the wrapper classes, right? So what we need, uh, someone will say, like, okay, put it into the array. But the problem with the array is, like, array is something not dynamically incremental. Let's say we create one array of 100, like, and what if we exceed that value? You will say that, okay, let's put a limit, like there could be array of 10,000 elements. But problem with that is that, if even if you are not required to keep the 10,000 employee or the student details, you need to create that much of memory. So unnecessarily you are creating or occupying the memory on your computer system. So we should have some way that we could keep different kind of heterogeneous information into one data type, or you could say, in this case we will say it collection. So it could be collection of a student, it could be collection of the employee, it could be collection of anything, right? So that is what we say. So because there are different ways of storing the information. It could be stack, it could be queue, it could be list. So we implement all those data structure into this collection. So what happens, like, either we could create our own data structure every time. Let's say there are 100 different projects, so every person who is working on different project, he will create their own uh, uh, code to have these all the different kind of data structure values, or Java itself provide these API. So in this case, what JDK do is, JDK has actually provided a library or a collection framework which you could use to store the information the way you want. What you need to change is, you need to change the type, right? So uh, before discussing all these things, like, array is not dynamic, and why we should not use the array. So let's say there is one example I have made. Let's say I have created one integer type of array which has, like, value of 1 2 3. Now I want to resize into the a size of 10, instead of, because there is requirement of new value. Let's say I need this 5 value here, so I can increase it. So how do I do that? So if I will put the debug point, let's save it. So I could simply uh, see, it is giving you the array of old, uh, size of the old array. I'm checking what type of data type it is saying. It is the integer type of wrapper class, and creating a new array with the size of 10, which is 10. I've given, this is the class which can give you a new object type. So it is saying integer type, the size is 10, and I am just preserving the last array length, which was the 3, and new is the 10. So, and I am just copying all those three values into the array, new array, which is the size of 10. If you see, it is occupying G1, 2, 3, that is 0, 1, 2 index value of the array. And you could see it is giving you the array with 3 already occupied and other 7s are none. So you could add a new. So this is how you could use it. But because every time whoever needs a dynamic array, he has to implement this method, right, in his own logic. That means it's a repetitive task. If something is repetitive, why a developer need to write it? So that's why JDK has given you the data structures with the already implemented class and the method, so that you could utilize in a better way, right? So that's why we need the collection framework. So the array is not dynamic, it is not dynamically incremented if we need. And to store the heterogeneous information, we need the collection. Also, it should be, grow and shrink frequently. If we need, we could use, like, utilize the three element. If we required, we could utilize only one. If it is required, we could use the 100. So it should be dynamically. And all these collection APIs are actually pre-written, well tested, and synced with the JDK. Remember this: whatever you code, if you will go to the enterprise level application, or the company where you are writing any application at enterprise level, you need to write and well test your application. If it is not tested, that is not qualified to send it for the production. So because all those collection classes and methods are written and well tested, you don't need to test it again in your local machine. So that's why it is coming with the JDK. And instead of implementing all these data structure again and again, developer can actually focus on the business logic rather than writing the code again and again. And because it is already, as I already said, like, it is very written data structure. So that's why we need the collection. So the collection that we are going to discuss, this is the structure. So at the top level, there will be always an object class, and below that there will be the collection interface. The collection interface will have, like, predefined methods. So all these interfaces, like the list, queue, and set, is going to implement the collection. That means all the method from the collection which is there can be used in the list, queue, and the set. And these are the classes which are implementing these interfaces. So the most widely used, and you are going to implement in your almost everywhere, is the array list, which is the class from the list. So array list is implementing the list interface. Another with the vector, which is nowadays people usually don't use. uh, I will explain later on, like, why, how do we implement the vector and why people don't use the vector. Another is the LinkedIn class, DQ from the queue, priority queue, hash set, linked hash set, linked list. All these classes we will discuss in our coming session. So another is the map, right? Map is also the part of the collection framework, but it is not part of the collection interface. Remember, this map is completely different from the collection interface. So for the map, we have the separate interface, which is the map, which is directly extending the object class. And map has the four different classes, that is hash map, tree map, linked hash map, and hash table. So all these we will discuss in the coming session. And the first thing that I'm going to discuss is the vector. Why I'm discussing vector instead of arraylist? Because vector came first, then people started using the arraylist and other thing. So I will discuss the vector first, then I will come to the other data structure. So at the top level, there is a iterable, and there is a collection, and there is a list, and the vector class. So all these are the interfaces, and vector is the class. Remember this, right? So vector is the class, which implement the list interface and allows you to create the resizable arrays, resizable, or you could say the dynamically incremental arrays. So another benefit of using the vector is that it is synchronized, right? So what happens, like whenever you insert any record or update or delete or do anything, there will be a locking operation. That means at a time there will be only one thread which is going to do any kind of operation on a particular vector collection or vector class, you could say, right? If multiple thread try to do the operation update, delete, or add into a particular vector collection, you will get the concurrent modification exception. That means this vector class is a thread save. Thread save, remember, this is a thread save. The initial capacity when you create any vector class, right, the initial capacity will be the 10 and load factor will be 1, and this is the formula for the growth rate. As soon as your capacity will be full, or it will reach at a particular threshold, remember this threshold, you need to resize your collection, right? So what happens, like let's say the initial capacity is the 10, right? Initial capacity is the 10, and you need to calculate the load factor, like at what uh, threshold you need to uh, create the new you need to add the new uh, you could say the space for adding the values into the vector. So for that there is a formula, like how you could calculate your threshold. So let's say the current capacity is 10, and you are saying the load factor is, for the vector load factor is 1. So threshold, that means 10 is already there. Let's say there is a uh, let's say this is the your vector, and it has the capacity of 10 initially. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So it start with here from this, that is 0 index, and it will reach at the here, which is the 9 index, right? Once it will fill all of them, then it has to create the new memory or the vector space. So it will create a new vector space. So for that you need to reach the threshold. That means once it is filled, completely filled, then only it will create a new space for the new values. So in that case, so the load factor will be the threshold, which is the 10 in this case. Load factor will be the threshold, which is 10, and uh, sorry, the threshold will be the 10 and multiply by the load factor. The load factor is in this case 1 only. So it will create another 10, right? So this way, as soon as your values will grow, it will create 10 slots with the new memories. So that is what the benefit of having collection, right? So this is how you could implement your vector. So if you will go to the example, let's say uh, let's say I'm saying vector, and I'm saying integer int vector equal to, I need to import it, the benefit of id is like I could simply import it. I don't have to write the code. New vector, right? Simply, in case of like after the Java 8, you don't have to write this as well. But yeah, if you are using the older version of Java, you need to write here. You need to give the type, right? And I could simply say int vector dot add one, right? And I could say int vector and 20, something like this. I could keep adding the values, and to print it I could simply use so control space bar enter int dot, let's say index of 0, right? So I could simply print it, right? It is saying -1. Why it is saying -1? It, okay, index of 0. So I need to get print the value. So it will send, I need to get the, let's say, first element. So it will say 10, or I could say the last element. It will say the 20, right? So this is how you could get the value for the first and the last, right? What if I will add more than 10 values? So for that you need to iterate it. To iterate, you could simply use, for now I'm using the for loop, which is the for int I equal to 0, I is less than int vector dot capacity and I plus plus, and I'm saying syso control spacebar enter int vector dot get. So I'm running it now. It will simply print the values. Capacity, okay, it is the capacity, so it is trying to get it. So I will do -1 because it will count it from the vector dot size. Sorry, instead of capacity, because it will give you the complete capacity, so we will use the size. So it is going to print you the values, right? So this is how you could implement the vector. This is a simple example. In coming session I will add more detailed examples for the vector.